The next wave came with the electrical power, electricity. Now, many of our earlier generation has experienced this. They've seen the industry running on electricity, the electric motor. In fact, Siemens was first to bring out the commercial induction motor. So this is the second wave, or industry 2. Now, this to this took almost, let's say, 40, 50 years. And then this was the 60s, programmable logic controllers. Not even 70s, it was 60s actually. And programmable logic controllers came because people started automating things by writing codes. The manufacturing area started using programmable logic controllers to automate the process. That means if I were to do something in a particular way, I use a programmable logic controller where I write a code, and the contacts that it would energize will make the process move. So this was the 60s, and this was industry 3. Then came the use of digital technology. The computers came in. So you all know from the 80s, and it started happening. What we see today is an extension of what happened from the level 3, which was the automation. Automation used extensively till the 90s. It moved into the use of computers, your human-machine interfaces, so you could actually do from the machine, you could automate the process, control the process. So all these things came already in the 90s. What changed between that and today is the use of information or the use of data. I remember, and this is just an example, 2008, we were launching a electric drive product, which was to automate a DC machine. And one of the colleagues then said, I wish the motor could talk. This was 2008. And we were in the audience, and we said, probably you are thinking too fast. Within 4 or 5 years, it actually happened. The motor started talking. So the induction motor, which Siemens introduced, which never talked, which worked, and people used to touch it to feel the heat, whether it's running okay, used to hear the noise, whether it's giving the proper vibration, the noise level, suddenly started talking, and talking throughout the day, like any human being. So this is what was happening in Industry 4. The entire machinery started talking. Now you see here what I've written on top, I've still not shown the connection, is called what I talked about, ERP. This happened in the 90s. The ERP already came. So the enterprise level was already getting integrated. You had the MRP runs, you had the production planning, you had the HR modules coming, you had the sales modules coming. So the enterprise level was already getting integrated. But there was no way to know what was happening in the manufacturing floor. So if you are running, you are producing so many products. So if you are running a factory, and if you are already planned based upon your orders, the orders come in, they are put into the system, there's a flow of scheduled orders which are going into the manufacturing shop floor. You have no way of knowing online what was really happening. If the machine was okay, if the machine was running on time, if the machine was producing or the machine was down, this was not known. So there was a huge gap, which was, everybody knew this was required, but there was no technology or tool to understand what was happening. And this was brought in Industry 4, which was really the integration of the shop floor with the entire enterprise. So, one term which could bind all those terms that I had mentioned earlier, all those various topics that I had mentioned earlier, artificial intelligence, IoT, cybersecurity, one term which could probably put all this thing together is integration. ERP had done that for the enterprise. Industry 4 wants to do it for the entire organization, right from the top level down to the last machine level. That is the intent of Industry 4. Intent of Industry 4. How we are able to do it, again, depends on us. How we can see the big picture, how we can see the issues, and how we can integrate it all together. I always say the best example of integration is ourselves. A human body is probably the best example of integration, because you always know when you are okay, when you are healthy, you always know what your right hand wants or what your left hand is holding or what your leg is supposed to do, how you are able to make a movement. The human body is probably the best example of integration. Now, our desire or will, or let's say the intent, is to make the entire organization in such an integrated entity. And this is the real intent of Industry 4. Again, according to me, you will go into the YouTube, you'll find a lot of explanations. But this is what I feel from my experience and from my discussions with various customers, this is the intent. Why I use the word digital transformation? Very simple. Because we are, let's say, used to do things in a particular way, but this is going to change a lot of things that we do and a lot of way we act. Therefore, it's a transformational journey. It will not be done in one day. It will not be done in small modules, or it will be done in small modules, but then you have to put it all together. You have to have that vision. So this is a transformational journey. It is not something that I have done and checked a box, that I automated this, so I have done so much of digitalization. Many organizations tend to do that. I always say, please don't do that. Rather, don't do it if you are wanting to do it that way. Now, to a few fundamental questions. Why do I do it? And this I have faced many times when I'm discussing with top CEOs, owners of organizations. First question is, what is ROI? And very, very correctly. What is the return on investment? I'm going to sink in so much of money. What is the investment return? So, but if you look fundamentally, what is the intent? I said that the intent is to make the manufacturing area better. If you look at, these are the 5 topics in general, which everybody is looking at. Sustainability, costs, I mean always top of the mind. How can I drive down costs relentlessly? Everybody will say, there are 2 things in business. One is, how much I can grow tomorrow, and the second is, how much I can reduce my cost tomorrow. Always the 2 things. So costs, whether by doing this, am I able to reduce my costs of manufacturing? That's a primary point of concern. Flexibility. I have today, let's say, 10 varieties of orders. Some variety is in some quantity, some other variety is in some other quantity, some variety is from a customer whom I know, we have such a long relationship that we want to do it fast. I want to have my manufacturing line flexible enough to cater to such needs. There's always a term which is very clear, very much used in manufacturing, rush orders. This is a rush order. Now, rush order flexibility, everybody wants to have, but it's very difficult to have. It costs money. Do you know how much it costs to make a rush order? Your systems don't allow you to know that. Therefore, flexibility is a massive concern. Time to market. Now, you have designed in R&D one of the products which is probably you think will be lapped up by the market. Now, someone else, your competitor, is probably working on the same. You want to beat the market before him and launch it into the marketplace. How can I cut my time to market? Another fundamental concern. Output, increased performance. Anybody will know whether if growth is my concern, I would like to increase my output. Can I draw more from the existing line? Can I draw with a little investment much more from the existing line? Now, these are the concerns which fundamentally have driven industry right from Industry 1 to Industry 4, whatever you call it. So whether it was electrification, automation, the quest was always this. Can I do it in a sustainable way? Can I do it at lesser cost? Do I have the flexibility of production? Do I do it faster than my competition? Am I going to increase my production much more from the same line? Now, these are the concerns which drive the industry, and these are the concerns which are intended to be answered by the integration of the entire organization. Let's come to having known the basic concerns, first, when you start, let's say, committing yourself to the topic of Industry 4 or digital transformation, the first thing is the vision. We had at one point in time introduced, we had a new lab for our motors, for our medium voltage motors. We set up a lab. And I was asked, that what is the return on investment on this lab? Now, when we look at the investment that we made into the lab, apparently there was no return. My answer was that the return on investment right now is zero. There's no return on investment. But 2 years down the line, you will not be able to sell these machines without this lab. So what is the return on investment? That means your sale goes to zero, because there is a ruling coming. If you don't have this setup, you will not be able to sell these machines. As simple as that. So therefore your return on investment is infinite if you want to remain in the product line. So that's the vision. Why do I need it? Is the fundamental question to ask. So if you see here, I have broken it up into two parts, the why and the how. You have seen all those terms, what we talked about, cyber security, additive manufacturing, so on and so forth, data analytics. This is the how part. How am I going to do it? But the first thing to ask is, why am I going to do it? Again, going back to those 5 points that I said, 5 genuine concerns, that is the reason. If you find that you are today possibly the leader and by far the leader, and you don't have any near competition, then probably you don't need it. Why will you invest? But think about what happens 2 years down the line. Will I be beaten off the market? Then I need it. Do you have the requirement of a much faster product introduction? Then you possibly need it. So if you see the why, this is the first beginning point. And to ask, why do I need it? If the answer is yes, then we'll go for it. But if the answer is no, by no means it is necessary to make a checkbox and say, I have done digital transformation. No purpose. It does not serve any purpose. So this is something which an organization must understand, and this is where the commitment from the top comes, the vision. What do I do with my organization? Where am I supposed to go in the next 5 years? From that comes the requirement, and that will drive the entire transformational program. Now, just to give you a view of what I was talking about, the integration. Now, this picture, how does it look? How does this picture look? Anybody? First reaction to this picture? Incomplete. A lot of white space. But this is what we see today, right? We have it. We have, I can see the machines, I can see the sensors, I can see acquisition network, I can see a SCADA over here, I can see data coming up to a level, I can see also a ERP running at the top. But it's a massive incomplete zone. And this is exactly what I was talking about. Today we are, half a human being in the industry. Now I'll start filling up the place. These are the various things that you want to do based upon all those fundamental 5 questions that you asked yourself. These are the things that you'd like to do. You may take out 1, you may take out 2, but these are the various things that you want to do. Is the picture complete? Now, what is missing? Integration, yes, integration. There's something else also missing. Look at here. And this I have faced in many cases. You walk into a plant, you say the intent is there, everything is clear, I do this, and then suddenly you find the infrastructure is not there. So which means, and this is in many of the cases, that means if you have an existing plant, in a new plant which is being rolled out, probably you will do this. But in an existing plant, you will not have. If I ask, do you have the network topology that is existing in your plant? People will suddenly start looking here, here and there, because they don't know. People have gone on adding various components, added networks, but they don't have a map of the entire network of the plant. Now, if you want to have a system which is going to talk to your entire organizational top level, and you don't know the network topology, you are bound to run into problems. You want to fetch data from all your machines. What is the bandwidth of your line? You don't even know. You may have to relay the entire, cabling of the plant. So therefore, these are the basic topics which you must, first think about, and there you need all the stakeholders of the organizations to come together. That means the manufacturing area owner who owns it, the engineering department who actually has designed it, or let's say continue to design it. So you need all of them together. Otherwise, this will always remain an incomplete picture. Now, this is something which is not visible upfront, which is something which is, again, coming from that vision and how the organization takes to it. A digital mindset. Now, why I say a digital mindset? A lot of times we feel that we have done enough, because if you, let's say, sharpen a pencil, you say this is sharpened. Now, how sharp is sharp? We do not know. And a digital mindset is exactly that you want to question always whether with the available engineering and the available tools that, or the technology that we have, are we doing the best? And if you are to decide whether you are doing the best, you also need to know whether all the information is available to you. How will you decide otherwise? So this is something which an organization needs right from the top down to the last man on the shop floor. And this is a massive, massive, massive issue. The cultural change or the mindset. The entire organization really has to be digital. I'm very happy. I mean, Mr. Bhanu was telling me that you have these sessions on various topics 12 times a year or something like that, you said, right? So, which is, see, getting yourself abreast of what's happening around is extremely important, and then it is up to you whether you want to take yourself to the next level. Probably the organization wants you to do that. And this is where the entire mindset change comes into the picture. If somebody is doing something on the shop floor, let's say for 20 years, he may have to unlearn and relearn. It is required. Because one very difficult problem in industry today and in future, as I said, the last generation could live with one technology for a long time. This generation or the next generation will not have the luxury to live with the same technology for a long time. They have to change. Otherwise, they become irrelevant. Very simple. They will become irrelevant. I keep telling the younger guys that if you are not changing yourself or your expertise over the next 3 years, whatever you are doing today, next 3 years, you should not be doing the same. Unless you do that, you become irrelevant. Your value will go down. Bound to happen. Technology plus people. Nothing works without people. All that we talk about technology, all that we talk about integration, all artificial intelligence. What is artificial intelligence? Can anybody tell me? What is artificial intelligence? What do you think about artificial intelligence? Very, very common term today, and very, should I say, abused term today. What is your idea about artificial intelligence? Sorry? Can you ever design a system without a human being? Except the human being itself, which came from nature. The artificial intelligence at the end of the day is human intelligence extended to machines. Artificial intelligence works on data acquisition and continuously upgrading the database. Who writes the code for that? Human beings are writing the code for that. So therefore, it's still the people. There is nothing artificial about it. People say people think it's a magic box. This is not a magic box. There are many machine learning engines in the market. Try taking one machine learning engine and put it into your system. It will never work. I can guarantee you it will never work. Because every machine learning algorithm which was prepared with a particular intent in mind. Your machine may be slightly different. It will not work. So you have to match the engine to your requirement. Otherwise, it will not function. So, very, very misunderstood and abused term is artificial intelligence. It is not today's. Artificial intelligence started in 88 or 87, somewhere thereabouts. In fact, when we were coming out of college, artificial intelligence was making its presence felt, hardly commercialized. It came into commercialization only in the, let's say, post-2010. Yeah? So therefore, what I'm talking about artificial intelligence is, again, look at that technology plus people. Without people, it doesn't work. So there is this misnomer, tomorrow no people will be required. Absolute rubbish. Cannot have the industry without any human beings. Infrastructure. I talked about the infrastructure at the beginning. I will not go much into the detail, but again, infrastructure is a very key element which people try to overlook. Because people try to say, my peer has done it, I will also do it in my plant. But without understanding the reality of the infrastructure. Two industries may be producing the same product. The other one has introduced a new concept of manufacturing. Now this one wants to copy him. But he has not gone into the details of the infrastructure. His entire transformation project is going to fail because he has not taken the care to actually build his infrastructure or tune his infrastructure. So it's a very, very critical point and one needs to keep in mind. I've just tried to draw a path of what this digital transformation is all about. We said trends and impacts, identify digitalization, focus area definition and prioritization. This all comes from that vision. All comes from, first starts from the right at the top, from the vision. And then you decide, you look at the trends. So these are absolute drawing board stuff. You look at the trends, you look at how the competition is behaving, how the market is developing, what is the need. So for example, today, if let's say an organization is supplying some food or packaged food to other countries, and he starts identifying that there is a need by the people who are taking in, or his customers, to actually track all the shipments to get a sense of commitment on the quality. Now, if this is what the trend is going to be, he has to have a proper track and trace solution in all his products that he's sending out. This is very prevalent in pharma, very, very prevalent in pharma, but may not be in all industries. But now many industries are demanding it, that I want to have a genealogy for all that I'm buying. Which means everybody who is supplying to that particular organization has to introduce that technology. Otherwise, it will not work. So market will push him away. So therefore, these are the trends. These are the overall area that the market is going. This is going to be decided, and based on that, you will decide what am I supposed to do with my new plant or with my existing plant. How am I going to go about it? So obviously, it starts with a maturity assessment. And this is something, again, what one must do. Where are we? In a current situation, where exactly is my position in terms of a, let's say, integrated production line? This assessment is very necessary. Without this, there is going to be a problem if you jump into a digital transformation project. So assessment of the current situation, the as is extremely, extremely important, and therefore there any organization will need a consulting exercise to be done. It has to be done. Because why do we say this? Because a consultant brings in an outside-in picture, because he doesn't know your nitty-gritties. But you know your nitty-gritties. Consultant can question you. I will take another example. Long time ago, we were in a large steel plant discussion, and we were discussing with them. And a consultant walked in, and he didn't have much idea about steel. He asked a question, what has got coke to do with steel? He had no idea that there's a coke plant inside a steel plant, and coke is not Coca-Cola. He asked the question, what has coke got to do with steel? And there was a lot of laughter in the room. Where does this guy come from? So, but this is exactly the point. It's not a problem. Let him ask. The consultant, if he asks those apparently stupid questions, can give you some wonderfully insightful, solution to your problem. So it is sometimes important to hear to those outside-in views. I also say at the same time that many a times organizations feel, I have given this order to a big consultant. Done. Now my thing will be done. He is going to end up in a big mess. Because the consultant doesn't know the integrities of the plant. No way he knows the nitty-gritties of the plant. How your plant functions is different from the other plant. Geography, demography, everything is different. So unless the organizational commitment is there and the key stakeholders are there together with the consultant to decide how to do it, it is not going to function. It is just not going to function. Coming to the topic of solution map, this is the job of the consultant, to work together with you to prepare a solution map. How it is going to go. How do you plan? What to do first? What to do next? So assessment will tell you whether your infrastructure is in the place or not. What do you need minimum to make the infrastructure ready? We talked about cyber security. Ma'am, you talked about the enterprise cyber security or the information technology. Now the moment you start connecting your machines, your plant is vulnerable. Anything can happen to the plant through some unintended malware. You don't even need, let's say anybody wants to sabotage you, it's not that. But due to some unintended malware which is residing in your plant network somewhere, the moment you connect it becomes active. You can have a situation. We have experienced such situations. Pharma lines production stopped because of a malware attack. And it was done, it was discovered that it was probably done because someone pushed in a USB somewhere just to download some screens. Probably it entered through there. Today we are at a risk of issues in our major pipelines, for example. Pipelines are connected. If there is a malware, it can create havoc. So therefore, the assessment of the plant security is extremely important and part of that infrastructure that I'm talking about. So this is the first step. The second could be the scenario definition and solution map. Now when I say scenario definition and solution map, let's say someone is developing or going to invest in a new plant. Now earlier days, a consultant will be called in, so he will do a site study, he will do a soil study, he will make all these information available, he'll make a drawing of the plant and it will go ahead with that. Now you don't know when you start making that plant what all obstructions in reality you will face, and that's why projects run into heavy delays. Today we have the tool and the technology to visualize that. Because at the end of the day, everything is based on certain facts and certain variables. So what we are able to do, and this is again one term you would have seen in the first slide, digital twin. You can or you are able to today make a factory layout exactly as it would be once you start making it. And you can put in the variables and see what happens if things go wrong. So you can actually predict it by doing the digital twin. Earlier days, simulation used to be done. Simulation used to be done on very small areas. Today, you can do, because of the availability of technology, you can handle massive amounts of data today. You can handle all kinds of variables, and therefore, you are able to visualize what happens to the plant if something goes wrong, which could be various, geographical effects as well. So therefore, when you are going into a new plant building, a digital twin always helps, part of the solution map. So these are the various paths to realize a digital transformation. One example from our own organization. We had a switchgear plant in Bombay where we used to produce our switchgears for a long time. And then we wanted to make that plant into a new plant based on the new technologies available, and we wanted to produce, like I said, more varieties of switchgear from the same line, So earlier we had 3 lines. Now we wanted to make one modernized line wherefrom I could take out the same products, the newer version of the products with, all the variations that are in. We did exactly the same. We did a digital twin of the plant. We made the digital twin of the plant. We took a look at that, what does it take to produce so many varieties, in what time, and based on iterations, we were able to make that plant in less than 2 years, and the result was fascinating. One line could produce 180 variants, which earlier 3 lines produced 22 variants. Now these are the transformations which are possible, but you have to do the homework well. If the homework is not done, then this will not work, because then it is bound to fail. So all these are part of the entire solution mapping and conceptualizing, and then comes the actual implementation. For a new plant, it is possible to do it in an entirety. That means you start doing it right from the word go, you employ all that you want to do. For an existing plant, this becomes a difficulty. And therefore, for an existing plant, you may have to take bits and pieces, start integrating in a particular way. So which again requires a proper planning in terms of the time of introduction. Consulting, implementation, optimization. What we call CIO, not Chief Information Officer, but consulting, implementation, and optimization. So I talked about consulting. Implementation is the phase when you realize all that whatever you have done in a digital twin or whatever you have done on the drawing board, you start implementing it. A lot of time this gets into delays. If the first part is not done well, there is an issue there. And then of course, once the plant is ready, it's still not the end of the story, because the market is not going to be, let's say, stable, or market is not going to be steady throughout its lifetime. It is going to keep changing. Therefore, the optimizations will have its role to play as you go forward. But at the same time, this optimization needs all the informations that are available in the system, whether it is drawn out and analyzed well. So therefore, that also becomes part of the consulting and implementation. So that's how this entire topic of CIO is a continuous process for a manufacturing plant to adopt, adapt, and be successful in the quest for excellent manufacturing. These are few examples what you could do. For example, integrated engineering. When I say integrated engineering, this is you could integrate your entire engineering process with your market intelligence and production. So what we call is a complete thread running from the market intelligence to the design and down to the manufacturing shop floor. So if the engineering department is, let's say, devising new ways of manufacturing a particular product, and the features which comes out of it, whether the market needs it, you also need that information in. Now this you don't need in a piece of paper. You need this to be also documented so that tomorrow something of that can be very useful while engineering the next phase. So these are the topics of integrated engineering. Asset performance management, we all know. I mean, these are, how much, the question was again, how much I can get from the existing. So asset performance management is a very typical topic. Process optimization, operations intelligence, logistics management, perhaps a little bit away from the, manufacturing area, but very key, because the products you produce has to go out. Now think of a massive metal industry, a steel plant, or for that matter, aluminum plant. For them, this is a nightmare, because inside the plant, in let's say every day, they're handling few thousands of trucks and wagons which are coming in. Different materials, trucks are coming in, trucks are going out. To manage this is a nightmare, and a lot of things happen there. Transparency not being there. Weighing of materials, what goes in, how much time it takes to turn around, what is the time within the in-plant movement. So And of course, the biggest of them all is a massive log jam at the gate, which is again taking away time of your product to the market. So integrated logistics management is a very big part of, the solution that Industry 4 is looking at. So these are the various applications that is available. This is the picturization of what I talked about in our own plant, where we did the digital twin of the plant itself, and then made the plant. This was the real plant layout. This was the digital twin of that, which was made beforehand, and this is the very normal product which comes out, which is a contactor, and this apparently looks very very simple, but when the order comes in, this will have so many variants. Somebody wants, I want 3 open contacts with 2 close contacts. Somebody wants all open contacts. Somebody wants 1 with 5. So all kinds of variants come in. I mean, very simple to look at, but very difficult to cater to the demands. Yeah. And this is what you see in every industry. So you walk into any industry, this is the part of the electrification. This you see in every industry. Drivetrain analytics, again, something very, very common, and which you can employ in brownfield plants, where you have your major problem is that my plant goes down because the conveyors, or for that matter compressors, etc., suddenly don't work. There could be bearing problems, there could be so many other different problems which nobody was aware of, because the maintenance was always in a certain periodicity, but something went wrong, nobody knew. Now this is where continuous drivetrain analytics helps. In a mill, for example, if there is an issue with a particular bearing, or if there is a issue with a particular gear movement, you will have a nightmare trying to solve it. But you need to have the knowledge or the information beforehand. We had a situation in a big steel plant where the main motor, which was generating the oxygen for the furnace, suddenly conked off, a 15 megawatt machine, and nobody had a clue what happened, because there was no online monitoring of the motor. But a 15 megawatt machine on which the entire production depends, and the repair time for that machine was 2 months. So you can imagine now what kind of havoc it plays in that plant. So therefore, these are the things which are very much today part of the solution, which are being thought of in brownfield plants, which are existing plants. But these are not the total solution. These are point solutions. You identify a problem, you try to solve it. But this is not the integrated solution that we were talking about. Yeah. But the technology today allows you to even look at point solutions, which could be your very sensitive problem points. I will not go into this in detail. And finally, I will just talk about this topic of cybersecurity, because when we integrate a plant, I said that the network is fundamentally very important, and most of the plants that I've walked in, people have no clue what the network is like. And they've never done the network analysis, never done network validation. They don't know who has added what in the plant. So this is a fundamental issue. But once you have done the network, the key point is to protect it, and therefore we always recommend that you do a security assessment from time to time, because vulnerabilities are changing. Even if I do a security assessment today, 1 year down the line there may be some new malware which is coming in. And trust me, very big organizations who are, the CIO told me, I have done everything in my plant, absolutely no problem. And when we did the assessment, we found most of his assets were exposed to the internet. He didn't know. Most of his manufacturing assets were exposed to the internet. And you have probably heard of this virus called WannaCry, which was let's say a year ago or a year and a half ago, there was a lot of noise about WannaCry. We found WannaCry residing in that plant. Dormant, not active, but it was there. So he was aghast actually that despite all that he mentioned initially, this was the situation. And this is unless there is a conscious effort to do it on a regular basis, you will not notice it till it hits you. So therefore, a very key part of all this that we are talking about is to stay secure, stay safe, and therefore the plant needs to be assessed from time to time. And of course, whatever firewalls or malware whitelisting, etc., you need to do that. You have to do. So by and large, I think I would have been able to give you a little bit of, let's say, a whiff of what Industry 4 is, and as we see it, and as I have experienced. Open to questions. Yes. I think you need a mic. Yeah.
Hello.
Yeah.
So I'm a fresher, and as my final year project, I had IoT. So we did double IoT, Industrial Internet of Things. So, sir, in this risks section, you said that we need cybersecurity, but we'll be using industrial big data, right? So when we are talking industrial big data, then big data will be stored in cloud. So we will also be open to risks from ransomware. So how we plan to tackle that?
So first of all, how do you reach the cloud?
Sir?
How do you reach the cloud?
Sir,
What is cloud?
So cloud is a digital platform where you store data.
Cloud is just another server.
Yes.
Right? So when you are uploading data into the cloud, it travels through your cables first, goes through your point where you actually connect to the cloud infrastructure through net or whatever, right? Once your data is in the cloud has its own security network to prevent any malware from attacking it. Yeah, so those are already there, and those are regularly upgraded.
Right.
Yeah, there's you will hear systems like disaster recovery. You will hear systems like regular maintenance window. So these are all to
So what we can do as an alternative, we can use the predictive maintenance chipset on so we can use the predictive maintenance chipset on the cybersecurity panel, so that we can develop sensors which can be automated to secure the server or not. We should if we do it differently, then that's just an extra cost for the company.
So your point, what you're trying to say is a little bit mixed up. So when you say that, why don't I do it right at where
By using predictive maintenance, yes.
which is let's say being deployed now with edge technology. So you do computation right on the device. Yeah, but again you have to see how much you can handle.
Yes.
Yeah. So suppose today you want to handle a massive plant, and you want to handle a small plant. The memory requirement or the computational requirement are different.
Yes.
So whether you will go to cloud at all, whether you will hire a cloud space, or whether you will do it inside your plant, depends on the amount of data that you handle, the amount of complexity that you have.
Right.
So that's exactly what you have to do when you are deciding on what to do.
Right.
See, you can do your all your memory store or all your data storage on cloud. You can do all your computation on cloud because of cost. Fundamentally, it's because of cost. Because you don't want to invest in the server at your own place. You hire a space, and you do it there. So this decision making you have to do. All the technologies are available, including what you are just saying. I do it right on the machine.
Yes.
Through edge. Then you have to employ edge devices in the bottommost layer. If you remember all those assets that I showed.
Yes.
So in the bottommost layer, you put all the machines with the edge devices.
Yes.
That's also going to cost money. So you have to look into the whole
A lot
thing.
of money, actually.
Yeah. So you have to look into the whole economics of the thing.
Yeah. Thank you.
Yes, please.
At an individual level, the organization will definitely, if they decide, they'll approach a consultant, get the study done and all that. And you also mentioned that there are some point solutions also. So at an individual level, people sitting in different departments, uh, how can they contribute or how can they take up projects? Is there a open source where they can go read about it, that this is available if this is my scenario? Uh, so like for example, sometime back in early 2000s, when Google was not that prevalent, there used to be various search sites wherein if you want to do coding, the codes would be already available. You need to know how to
You
search.
were talking of the days of Yahoo and Excite and
Yeah.
Metacrawler, etc.
So how do we?
So, no, I mean, from our side, let's say from Siemens, we have two ways, yeah. You can, we have a Siemens Access program where you can buy the access license and your people will be able to get the, regular snippets on that. So access is available, which doesn't cost much money. So Abhishek, you can just tell them. So access is one. The other is we also do customized training programs, which could be done online as well. So we have online training programs where we can do, with a group of people, you can have an online lab as well, so they can practice it from where they're sitting. So these are the two possibilities from Siemens. Otherwise, of course, you have N number of today, digital courses which are available on the net. But from Siemens side, these are the two options that is available to you. Any other question? Yeah.
Good afternoon, sir.
Good afternoon.
One query. So, with digitalization, all the equipments will be connected, through PLCs, and there will be, I think, background software which will be running, taking care of the parameters of the machines and all. So, there will be nothing like manual intervention on the equipments, I believe. There would be, but the main operating of the machine would be controlled by PLCs. So what if the software gets bricked? Suppose it gets stuck. So I think, does it cause, loss of operation, loss of production, or how do you counter that? Because
So-
I understand there is safety, security, predictive maintenance you're doing in between.
So every automation system does not have a, let's say, a hot redundant system. So there is a possibility of breakdown, of course. So there is no system which is 100, and again, it depends on the cost. You can put in a let's say, fail-safe, redundant system. It costs money. So it depends on the criticality of your process. For example, in a steel plant, if you are operating a blast furnace, you have a fail-safe automation system. So if there's a failure, it takes over. So, and you can attend to it even while the blast furnace is running. So it again depends on the kind of criticality you have and the solution. If you have a system or a solution which is not very critical, then you probably don't need a fail-safe or a redundant system. Yeah,
Okay.
these are available.
Understood. Thank you.
Okay, so I think no further questions as I understand. So happy learning. I mean, keep your minds open. Go through you have all access to the net. These days net is available everywhere. So actually we are living in an age where, whenever somebody asks a question or says something that I do not know, I immediately look into my phone. So the encyclopedia is now, obsolete. It's on the phone itself. So happy learning, and thank you.
Thank you, Mr. Roy, for this wonderful session and the insights that you have shared on the digital transformation journey for any of the manufacturing organization today. I would now request Sinha sir to please come and conclude the session for us.
Thank you very much, Mr. Bireshwar Roy. A very captivating session. I think most of us here, they are aware that we have embarked on this journey for digital transformation. the intent of the management, as I was sharing in the morning, is very clear that we want to experience it, we want to go through this, and we want to actually transform. And beyond the 5 drivers you spoke, which would mean sustainability, flexibility, cost, speed, output, there's one more driver that we are looking at, that is governance, especially the carbon footprint and the decarbonization. Okay, so we are looking at it. It is not only our desire, it is a compulsion also, because that is what our customers expect us to do. Yes, we want our products as well as our factories to talk, and that is what it is all about. Talking about the experience part of it, the reason we decided to go with only the Dahej plant was first to experience and then to extrapolate and have all other plants go digital. It is going to be very interesting for all of us, and thank you, Team Siemens, for partnering with us for the journey. One last thing, you also spoke about pace, and I just can't, hold back sharing that in late 80s, 90s, I read a trilogy by Alvin Toffler. Especially the third wave and the future shock. And it spoke about all that we heard in the last 1 hour, 15 minutes. It spoke about how, the green revolution took, about 3,000 hours, industrial revolution would be 300, digital revolution would be 30 years, and then it would be much quicker every few years. So we are experiencing it. Maybe we are very fortunate to experience it. So pace is what has changed. Maybe we are, especially people like me, we have experienced all of it, and the future, all of you young people, you'll be experiencing more and more technology and very often. So once again, thank you, Mr. Roy and the team Siemens here, and thank you for being partners with us in this journey.
Another good, right? So he's your senior.
Thank you everyone for joining us for our next session. Thank you.
नहीं लंच